Hello, I'm Jose Cordeiro, originally from South America, but working in the USA, in Japan, Russia, and in South Korea, talking about technology and space technologies in particular. I began my studies at MIT, at the Massachusetts Institute of Technology, and I did my master's thesis on the International Space Station, which in the early 1980s, it was called the Freedom Space Station. This was an original project by NASA during the Cold War. In fact, it was called the Star Wars operation because the Freedom Space Station was going to be used to monitor the Soviet Union and to have lasers against any Soviet rockets or Soviet equipment. So my master's thesis at MIT was exactly about the dynamic behavior of the Freedom Space Station, because it could be hit by other rockets, by comets, asteroids, or anything, another space station hitting the Freedom Space Station orbiting our planet. So this was a fantastic experience. I have loved space ever since. I was working at NASA at Langley Research Center, which is outside Washington, D.C., and they have incredible scientists, incredible engineers working about the future of humanity and the importance of space. So space is very dear to me, and we live in a very small planet, in a very small solar system, in a very small galaxy, in a huge unknown universe. The future is fantastic, but we need to colonize the rest of the solar system, and then eventually the rest of the galaxy, and then maybe, hopefully, the rest of the universe. I have been so interested in space studies and science fiction that I went to interview Sir Arthur C. Clarke, who was a very famous science fiction author. But actually, he was an electric engineer. Before beginning writing, he actually graduated as an engineer in England in electric engineering. And during World War II, he devised this system of satellites orbiting the planet used for telecommunications. So this is in fact called the Clarke orbit. This is the orbit that communication satellites use today. And when I interviewed him in Sri Lanka, he lived in Colombo, Sri Lanka, near India. And he was a fantastic person because he loved space and he loved oceans. He always loved to go into the oceans, deep into the seas. And those two systems are very similar. Going into the oceans and going into outer space are very similar in a way, because you see how fragile our bodies are. Our bodies are truly, truly very fragile, and we can die very easily. So we need a lot of supporting equipment to go into the oceans or to go into outer space. Arthur C. Clarke actually had a scuba diving center in Sri Lanka. So if you wanted to do a scuba diving, you could have gone to the center that Sir Arthur C. Clarke had in southern Sri Lanka. Anyway, when I interviewed him, and you can read this interview in internet, it's published, available in internet. I asked him about the future of humanity and if he was positive or if he was negative. And he said that we actually have to be positive about the future because many of the things that we believe are self-fulfilling prophecies. Therefore, if we think we are going to die, we are going to destroy ourselves, we are going to have a nuclear war, we are going to have a Holocaust, then it will probably happen. But if we think that the future will be better, that we will transcend our limitations, we will overcome our problems, we will colonize the space, then it will probably happen. It begins in our minds. So these are self-fulfilling prophecies. And Sir Arthur C. Clarke has another very interesting quote when he was asked if he believed if there is intelligent life in the universe. And he said he was not sure. In fact, he said he was not even sure if there was intelligent life here on planet Earth. So that we might not have intelligent life here in our planet, according to him. But he was very intelligent, so certainly we do have intelligent life in our planet. Sir Arthur C. Clarke is also very famous for the 3 laws of the future that he wrote half a century ago. These three laws of the future are really, really interesting, especially because he wrote them so long ago, when technologies were very primitive compared to what we have today. Before we went to space, before going to the moon, he wrote these three laws. First law of the future. He said, when a famous scientist tells you that something is possible, he is probably right. But when he tells you it is impossible, he is probably wrong. That is a very interesting law. Second law of the future. The only way of discovering the limits of the possible is to venture past those limits into the impossible. So that we really need to experience beyond what we see, beyond what might be possible today. And the third law, any sufficiently advanced technology is indistinguishable from magic. This has a beautiful corollary. If you see a technology that does not look like magic, it's because it is not advanced. Okay, so let me tell you about some of these magic technologies that we have seen in the last few decades. Let's start with computers. We did not have personal computers 30 years ago. They were just beginning, personal computers. 20 years ago, we were just beginning also with mobile telephones. And today, everybody basically around the planet has a smartphone, or at least has a mobile phone, and most of them will soon be smartphones. And this just began 20 years ago. Also 10 years ago, Google was beginning, Wikipedia was starting, Facebook was a baby 10 years ago. So imagine what we have seen in the last 30 years and think about what we are going to see in the next 10 years, 20 years, 30 years. And as Sir Arthur C. Clarke said, any sufficiently advanced technology is indistinguishable from magic. So we are going to see magic. We are going to see incredible things in the next few years. In fact, so many big changes we are going to see in the next few years that I like to say that in the next 2 decades, in the next 20 years, we are going to see more changes, more advances than in the last 200 years. So in the next 2 decades, more changes than in the last 2 centuries. We live in incredible times. We live in a world full of possibilities where we can do almost anything that we can dream. And one of those dreams, obviously, is going from our planet Earth into other planets, and not just the moon, right, which is a satellite, but going to Mars. And that would be the beginning of the space exploration. Okay, with all of that, I want to tell you about exponential technologies because things are changing exponentially. And for us, for humans, it is very difficult to understand the nature of exponential change because we think linearly. Humans think linearly. Therefore, it is not in our brain set to think exponentially. But let me give you a comparison. If I give 30 linear steps, 1 step, 1 meter, 2 steps, 2 meters, 3, 4, 5, after 30 steps, I have walked 30 meters. This is linear thinking, okay? Linear steps. However, if I go exponentially, doubling every time, so the first step is 1 meter, the second step is 2 meters, the third step is 4 meters, the fourth step is 8 meters, the fifth step is 16 meters, and then 32, 64, 128, and so on and so forth. We are basically growing exponentially. And so after 30 steps, I will have walked 1 billion meters, 1 billion meters. And I could have gone around planet Earth 26 times. So look at the big difference between exponential change and linear change. So exponential walking lets me go around planet Earth 26 times after 30 exponential steps. But linear walking lets me walk only 30 meters. So this is a big difference. I'll show you how this works in technology. One of the most famous examples of these exponential changes is Moore's Law, which is based on Gordon Moore. Gordon Moore was one of the founders of Intel, the company that makes the chips in computers. He discovered almost half a century ago, also in the early 1960s, that computers were doubling their power every 2 years, and that their price was going down every 2 years, every 2 years, every 2 years. Actually, now this is accelerating, and now it's only every year and a half, every 18 months, computers double their power. And in fact, this could increase even more, because now engineers and scientists are working on three-dimensional circuits. All the circuits today are flat. They only have 2 dimensions. Imagine going into the third dimension. So how much power can you put in a computer when the circuits are 3D circuits? I'll give you an example of what has happened in the last 30 years, showing some of the memories that we have used throughout history. These were very popular 40, 30 years ago. These are mechanical memories, and we use these also to record information and to write programs. I used this 30 years ago. This basically has 10 rows times 100 columns. 10 times 100 is 1,000. So this is 1,000, 1K of information that we used 30 years ago. But these mechanical memories, after you made the little holes, you could not change. Therefore, they had a big problem. It could be used only once and it could not be modified. Therefore, the first electromagnetic memories were invented. And this was used 30 years ago. This is 8 inches big, and it also had 1K of memory. But this 1K electromagnetic was better than this 1K mechanical, because the electromagnetic system you could erase, you could change. So 1K mechanical, 1K electromagnetic, that began an incredible exponential change. From this, we moved into this, which is much smaller. This is only 5¼ inches. However, it has a 512K of memory, 512K. And then from this, we moved to even a smaller floppy disk of 3½ inches, and this had 1.4 mega. 1.4 mega. But now we are moving even faster. And actually today we have pen drives like this, which are basically like Lego pieces that you can connect in the back and increase, let it grow. And this one has 128 gigabytes. 128 gigabytes. So look what has happened in 30 years. We have moved from 1K of memory to 128 gigabytes. This is amazing, what we have seen in the last 30 years. But it will be even more amazing in the next 30 years. And probably in 30 years, you will see this talk again, and we will have a device much smaller than this that has more transistors than our brain has neurons, okay? More transistors than we have neurons, okay? And that actually could be the beginning of the technological singularity. The technological singularity sometimes is defined as the time when artificial intelligence reaches human intelligence level, okay? And that will happen when we have devices that have more transistors than we have neurons in our brain, and therefore computers, robots, artificial intelligence will reach human intelligence levels and then improve. And we will probably be connected to this artificial intelligence. We will be in a mega cloud connecting our brains to these other external devices to improve our brains, our memory, our speed. So this is an incredible change that we are seeing in computer science, but also in other technologies. I'll give you another example in biotechnology, which is related to the human genome. This is a gene chip to sequence the genome, a gene chip. With this device or something similar, you can sequence your genes, and you can discover what you have in your genes. You will discover the color of your eyes. If you didn't know the color of your eyes, you will discover the color of your hair, because it is all in your genome. You will see the probability of having certain diseases. What is the probability that you will have Parkinson's disease or Alzheimer's disease or diabetes? What is the probability that you will have many diseases? So once you sequence your genome in the next few years, you will know not only the color of your eyes, but you will also know what diseases you might have statistically. And you might discover what you might die of in the future. But knowing that, you will prevent it. You will not die of that because the medicine of the future will no longer be curative. You will not cure diseases in the future. You will prevent diseases. You will have no diseases in the future because knowing what you might have, you will prevent those diseases. You will be able to modify your genes, to improve your genes so that you don't have those diseases. Now let me tell you about the exponential technologies involved here in this biotech system. The first human genome was sequenced after 13 years. The Human Genome Project began in 1990 and it finished in 2003. And it cost $1 billion to the US government and close to $2 billion by other governments because this was an international project. So almost $3 billion from all over the world after 13 years. Think about that. 13 years from 1990 to 2003 and almost $3 billion. Today, 2015, you can sequence the whole genome for less than $1,000 in about 5 days, 1 week. But we expect that in 10 more years, in around 2025, you will sequence your genome in 1 minute for $10. 1 minute and $10. So let's review the numbers. The first human genome cost $3 billion and it took 13 years. Soon in the future, in the next 10 years, you will sequence your genome completely and better than in the past for $10 in 1 minute. That is absolutely incredible. That is truly exponential. And it is exponential in two senses. Exponential in terms of time, going from 13 years to 1 minute. And it is exponential in cost, from $3 billion to $10. That is magic. As Sir Arthur C. Clarke would say in the third law of the future, it really is magic. And so all technologies are changing this fast. First, information technology, now biotechnology, and very soon, nanotechnology also. Nanotechnology. Nanotechnology is probably running 20 years behind biotechnology. So all the big, incredible changes that we are seeing today in biotechnology will happen again with nanotechnology in the next 20 to 30 years. So all these technologies are moving very fast, they are changing exponentially, and they will change the world, they will change humanity, and they will change humans. We humans, we are going to be changed by this technology. We will be modified, we will be enhanced, we will be improved with this technology. Like many things we use today, these glasses, they enhance me, they improve me. I prefer to see you with my glasses because I see better, okay? So we have many technologies that enhance us, they make us better. Our computers today, our smartphones today, almost every technology we have, also in medicine, many technologies in terms of living longer, living better, living healthier. And this is only getting better and better. Remember, in the next 2 decades, we are going to have more changes than in the previous 2 centuries. We live in absolutely fantastic times. We are seeing incredible exponential change that are going to help solve most of humanity's problems.